Good morning, student. Today we will begin with lecture number 20, Simple Stresses and Strain. Topic, Numerical on Steeped Cross Section. We will continue with the topic which we have taken in our previous lecture. We will solve two more numerical today. First question. The bar is as shown in figure. Find stresses in the three parts and total extension of the bar. Take E is equal to 2 into 10 raised to 5 Newton per mm square. Now given E is equal to 2 into 10 raised to 5 mm square. Diameter D1 30 mm, D2 20 mm, D3 32.5 mm. L1 is equal to 180 mm, L2 is equal to 260 mm, L3 is equal to 160 mm. Pull force is equal to 40 kilonewton. This is the diagram. We have pull force 40 kilonewton tensile, and we have divided into three parts 1, 2, 3 of different cross section. We will solve the problem. Area 1 is equal to pi by 4 d square, that is 30 square, is equal to 706.86 mm square. Area 2 pi by 4 20 square. Area 3 pi by 4 32.5 square. We know delta, that is total change in length throughout the bar, is equal to delta 1 plus delta 2 plus delta 3. Now here, if you see, delta 1 is the change in length for section 1, delta 2 the change in length for section 2, and delta L3 is the change in length for section 3. We have already derived this formula. We have seen this formula in our previous lecture. Same formula we will apply here. So by using this formula, and substituting the value. So here we have substituted the value P 40 into 10 raised to 3 divided by E 2 into 10 raised to 5 in bracket. We have length 180, and that is L1 180, A1 706, L2 260, A2 314, L3 160, A3 829. Solving, we get delta L is equal to 0.255 mm. 0.255 mm. I hope you understood the same problem. This is a problem in which only the cross section at various length is changed. That is stepped cross section bar, stepped cross section bar, or varying cross section, or varying cross section. I hope it is clear to you. The second question. A circular bar of 1000 mm length has cross section as given below. First 200 mm has a diameter 10 mm. Second 500 mm has a diameter 25 mm. And the last 300 mm length has diameter of 15 mm. Determine the maximum axial pull which the bar may be subjected if the maximum stress is limited to 150 MPa. Find total elongation of the bar. Take E is equal to 200 GPa. So complete bar length 100 mm, 1000 mm, sorry, 1000 mm. First 200 mm, then second length, first length 200 mm, second 500 mm, and the last 300 mm. We have to draw it. The diagram is not given. Now let's see how the diagram comes. Yes, so here divided into 3 sections, 1, 2, 3, with varying diameter. Diameter 1 10 mm, diameter 2, diameter 3 15 mm, length 1 200 mm, length 2 500 mm, length 3 300 mm. P pull, tensile pull as shown in the diagram. Now this is a case of just varying cross section. यहाँ पे जो हम देख रहे हैं, यहाँ पे P एक्चुअली अप्लाइड है, यहाँ पे एक ही मटेरियल से बना है पूरा 1 2 3 सेक्शन एक साथ, तो यहाँ पे ई बी कॉमन सेम ही रहेगा सबका. यहाँ सिर्फ डायमीटर बदल रहा है, अलग अलग सेक्शन में अलग अलग डायमीटर D1 D2 D3, और वैसे ही लेंथ L1 L2 L3, corresponding length L1 L2 L3. Let's solve the problem. Now what it has given? It has given that the maximum stress is 150 MPa, that is 150 Newton per mm square. After drawing the diagram, we have find the cross section area, pi by 4 d square. So for cross section area A1, pi by 4 10 square. Cross section area for section 2 A2, pi by 4 25 square, and cross section area for section 3 A3, pi divided by 4 15 square. So we have A1, A2, A3. Now we have to determine the maximum axial pull. P is equal to maximum axial pull. The maximum stress will be developed in the portion having minimum cross section. यहाँ पे ये देखना जरूरी है कि मैक्सिमम स्ट्रेस कहाँ होगा. तीनों क्रॉस सेक्शन एरिया अलग अलग है, तो जहां कम क्रॉस सेक्शन एरिया होगा वहां स्ट्रेस मैक्सिमम रहेगा, वहां मैक्सिमम स्ट्रेस रहेगा. क्योंकि लोड सेम है, एरिया कम हो जाएगा तो स्ट्रेस बढ़ जाएगा. ठीक है, स्ट्रेस इज लोड दैट इज P डिवाइडेड बाय एरिया. तो P तो कांस्टेंट है, एरिया जो नीचे डिनोमिनेटर में है वो कम हो गया तो स्ट्रेस बढ़ जाएगा. तो यहाँ पे सेक्शन या पोर्शन 1 में मिनिमम क्रॉस सेक्शन एरिया है. ठीक है, सो सिग्मा इज इक्वल टू सिग्मा दैट इज स्ट्रेस इज इक्वल टू P डिवाइडेड बाय. नाउ मैक्सिमम स्ट्रेस डेवलप हमको दिखाया गया है 150. तो स्ट्रेस कितना है 150 इज इक्वल टू P divided by cross section area of area 1, that is 78.5. Substituting the value, solving, we get P is equal to 11780.97. Next, now we had find P, we need to find total elongation. Total elongation delta L for the complete bar is equal to delta L1 plus delta L2 plus delta L3. Formula same, delta L is equal to P divided by A in bracket L1 divided by A1 plus L2 divided by A2 plus L3 divided by A3. Substituting the value, delta L is equal to P is 11780 divided by E 200 into 10 raised to 3 in bracket L1 200 divided by A1 78.54 plus L2 500 divided by A2 490.87 plus L3 300 divided by A3 176.71. Solving, we get delta L, that is elongation for the complete bar, is equal to 0.31 mm. 0.31 mm. So this is for the today's lecture. Thank you.